ultimate is seeing is believing. In all the other logging methods, we have indirectly inferred about the subsurface. Today, cameras are available at a competitive price. So underwater camera system can also be deployed. So video camera, all of us have a camera in our mobile phone today, right? So similar camera system, of course, it has to be developed with much more stringent tools. It has to be developed so that it work under stringent conditions and tough conditions of high pressure of borehole fluid or groundwater. It has to be produced in a leak-proof method way, and this can be helpful to understand what are all the different formation in the borehole. Obviously, in a uncased borehole, right? In uncased borehole, so in borehole camera, we are going to make use of underwater camera video systems for viewing the wells or bore wells or water wells. This can be also done in two different methods. One is a vertical viewing camera. The camera views vertically, that means the camera lens is something like this. In another method, the camera can be looking the sides, looking at this, maybe 3 or 4 cameras to look at all the 4 sides of the borehole. So we have different arrangements that are available. So we can use the method which we want to understand and see what is the formation below the surface of the earth. So finding this helps us to understand the zones that are polluted. It helps us to delineate zones that are affected by groundwater pollution, and also we can literally see whether there is any groundwater contamination or contaminated groundwater is flowing into the wells. Suppose if it is half different color, otherwise it is difficult, right? That means we are literally seeing the flow of water, right? So everywhere the water may be like stand still. At some places you can also see the currents, right? Movement of water in conducive conditions, right? And we can also find and view the fractures in the rocks, right? Suppose if you are carrying out borehole camera logging, we can see the fractures, whether there are any cracks and voids. As I told you, water currents, right? And we can see cross or interbed water flows. All this can be seen, right? And we can see if the groundwater entering into the well is little bit discolored, we will be able to understand that. And viewing the actual conditions help us to literally have the feel of the subsurface formation. And obviously, it can help us very clearly to distinguish the termination of the well casing and well screen, right? Sometimes the well would have been completed and it is in operation, right? This is the ground surface, right? The well is in use, there is some issue with the well, right? The well yield would have got reduced, then we may need to inspect the well. For that, we can often use the borehole camera system, right? This is the screened portion. So well screened is the portion of the cased well where there are some slots provided for the water to enter into the well. These slots would have been completely damaged or clogged due to several reasons: physical, chemical, or biological clogging. Right? This can be also checked by lowering the camera. Right? In certain cases, we may use what is known as a packer. Packer is a inflatable system usually used for grouting purpose or to isolate a particular zone to carry out tracer tests. Right? This is the borehole. A drilling rod is lowered. The drilling rod will have a inflatable balloon-like thing here, which is connected with a small pipe to the surface, and by releasing a gas, this balloon can be inflated, right? So that it completely seals the annular space between the drilling rod. This is the drilling rod and this is the formation, right? So this zone is completely sealed. Then you can inject the tracer here so that the tracer is focused only in this, flowing only in this particular zone. This is one of the application, right? Whether the packer has properly placed or inflated can also be checked with the borehole camera system. And we can also test whether the casing is intact or corroded. Sometimes due to high groundwater pressure, the casing itself may get bulged inward, right? That means the diameter of the well gets reduced, which can be also detected by caliper log. And also to check the conditions, is it corroded, can be done using the borehole camera. And drive shoes are the bottom of the borehole. All this can be tested. Suppose if we have used steel pipes by welding, the welded portion can also be checked using the borehole camera system, right? And this method helps to understand and troubleshoot and to determine the actual condition, because in all the other methods we have indirectly understood about the subsurface, whereas here we are literally seeing the subsurface. So here is one such borehole camera taken at a particular site in so here you see a video of the borehole camera taken from a depth of 2006 feet. Sorry. So here we are looking into a borehole camera logging carried out in a limestone terrain in India, where we see a particular part alone. We are looking at the variation in the formation from 206 feet beneath the surface of the earth, where you can see the caverns and how the limestone got leached can be seen using this borehole log. We have seen different logging methods. All the logging methods which we have performed, which we have seen, are carried out after the completion of drilling. And some of these methods can also be available or can be done using a technique known as logging while drilling. That means when the drilling is under progress, simultaneously also we can do certain measurements which are indispensable, especially in oil industry, right? These are all some of the logging tools which are also tied up with the drilling equipment. So as the drilling is proceeding, simultaneously we get information on natural gamma log, resistivity, density, that is gamma neutron logging. This is recently they have also brought in sonic logging, pressure in the formation, right? Formation fluid sampling, right? Also caliper logging. These are all done. Many of the scientists who are employed as loggers, right? Their job during oil well drilling is to continuously monitor all this information. This technique is known as LWD, meaning logging while drilling. So we have seen different logging methods, and as I was repeatedly telling, we never depend on one particular log. To get the maximum information, logging is done in combination of several logging methods. We have seen many, more than 10 logging methods we have seen. So we have to ideally mix and match different logging methods to answer the questions we have. To answer the questions, interpretation is done always by corroboration. That means interpretation obtained from different logging. For example, just now we discussed NMR gives porosity, gamma logging gives porosity, resistivity also gives the formation porosity approximately. So we have to compare. If there is wide difference in the value we have got, so something is wrong. If all of them are reasonably comparable, then our interpretation is likely to be very, very correct. So this is how we compare one with the other to come out with the meaningful interpretation. Due to this reason, we need several zone days. Right? Several zones are necessary. Due to this reason, logging is actually a very expensive. Logging is actually very, very expensive. Each tool may be very, very expensive. When we need to use different tools to come out with a meaningful interpretation, the whole exercise can be very, very expensive. Right? However, very critical questions we are able to answer by being at the surface. We are able to understand and identify the boundaries between the formations precisely. The clay is 1.34 meter thickness, then followed by that shale, followed by that sand of 43.4 meters. Like that, we are able to precisely demarcate the boundaries of different formations. Further, we are able to get some properties: density of the formation, porosity, percentage saturation, how much of the pores are filled with water, how much of pores are filled with oil, right? I hope you can recollect the Archie's formula we had seen, experiment we had seen, in which he has carried out a series of studies in sandstone by carrying out the estimate of resistivity by mixing oil and water in different proportions, right? So we are able to understand the percentage saturation in the pores. We are able to also understand about the dip of the formation. So what is the dip of the formation? So in the borehole, if the rocks are inclined, we are able to determine the angle of inclination, right? And especially fluid conductivity logging, fluid temperature logging, both of them will give comparable results that indicates interaction between the borehole fluid and the surrounding formation water. Right? So these are all some of the applications due to which logging is indispensable, especially in oil well drilling, also in water well drilling. Whenever you are drilling for a high quantity production well for supplying water to a major city, logging is indispensable to locate zones which can be suited for tapping water, right? We would have drilled a 200-meter borehole, but we have to identify zones that is likely to produce more groundwater. Over there only we will provide screens. Similarly, in oil well drilling, we identify zones which are highly porous and permeable within the pay zones, within the oil bearing zone. Only that zone is punctured, right? Casing is lowered. After that, the casing pipe is punctured, right, with a gun. So that zone is identified by logging. Right? So these are all some of the applications of logging methods. Right? As I told you, we never stop only with one particular log. So here is an example available at this site, right, to show you how different logs are compared with one another. And the most important thing is caliper log that gives information about the change in the diameter of the borehole. The diameter of the borehole is measured. The diameter of the borehole changes because of the presence of mud cake. Large amount of mud cake would have formed, or at some places washing out of the formation would have happened, wherein diameter will be more. Where there is a thick mud cake, diameter gets reduced. It also has to be correlated with the response of all the other logs. So here you can see neutron log measures the presence of water. That also estimates porosity. Gamma gamma log, which is density log, that also estimate porosity. Resistivity log, right? Shallow and deep resistivity. Natural gamma logging, right? Here they have used radioactive spectral logging. That means radioactive logging, the total amount of radioactivity is also segregated from in such a way that amount of radiation from potassium, thorium and uranium. So using which it is very indispensable in mineral exploration, right? So wherever we have higher amount of uranium, they are all potential zones for further exploration, mining of uranium. Right? So here is the sonic log. So here again natural gamma ray logging. So this is how all the logs are compared, kept one after another. They are compared to make meaningful identification of the boundaries between the different formations. Right? And here is a big table in which I had put what is the question which we have, what technique we can make use of. Suppose our interest is to demarcate the formations. Then different boundaries have to be identified in a borehole. Then we can make use of electric log, sonic log, caliper log, because caliper log, the diameter of the borehole will be exactly same in some tight formation, especially in shales. Right? The diameter will be the same. Whereas in the case of sand, diameter would have slightly got increased if the sand is a loose sand, because sand would have been during drilling would have got partly washed out. Right? And nuclear logs. Right? If it is an open hole, these logging will help. In closed holes, none of them are possible. So only option we have is nuclear logs. Then porosity or bulk density also can be estimated from sonic logs or neutron and gamma gamma logging we had seen already. Porosity and resistivity possible from resistivity logs. Estimate of porosity from the resistivity logs. Presence of clay and shale content, very easy from natural gamma, because clays and shales will have more radioactive minerals. Counts per time will be much more in zones where we have clays, which can be determined by natural gamma logging. Permeability, we have just now seen. Directly we are not estimating the permeability, but we are estimating the permeability using some algorithms as well as empirical formula by estimating the porosity, right? So we are able to determine the permeability by, or we are estimating the permeability from the porosity estimates we have made. And we can also to understand about the permeability from injectivity or from NMR, wherever you have mobile water is much higher, possibly indicating higher permeability, right? That means we are not directly estimating permeability, but indirectly we are deriving the permeability values, right? And also using sonic logging, right? In sonic logging, what we can do, we can inject water before and after. Also, we can try carrying out logging to understand the effect of the pore fluid which we have injected into the water. That will give again an idea about the porosity. Then porosity can be transferred to permeability. Right? Then presence of secondary pores, especially in rocks and limestone formations, right? Where even in the borehole camera video, you would have noticed the presence of secondary fractures in a limestone terrain. This can be estimated by borehole camera and sonic as well as caliper logging. Specific yield of the formation can be estimated from neutron logs as well as NMR logging. That means specific yield is the difference between bounded water and the mobile water, right? Then grain size also can be estimated from NMR, particle size, and here too we can estimate this from the electrical logging methods. Location of water level, very easy from all these logging methods, especially electric logging methods as well as neutron gamma logging methods help us to understand the location of water table. Right. Moisture content, the best is the nuclear logs, right? Especially in radioactive logging, neutron logging method works on the principle of presence of water, right? Similar to NMR, we are able to estimate the moisture content, especially in the unsaturated zone, using neutron logs. Infiltration, right? So infiltration can be understood from time interval neutron logs, right? That means if you want to understand the effect of some recharge ponds before injecting water, before stagnating water on the surface, we can carry out a neutron log in the borehole adjacent to that or in the middle of that such structure. Then we repeat. That can be possible by neutron logs. We had seen such a thing under resistivity method. I showed you an example of carrying out resistivity tomogram adjacent to a percolation pond. Similar thing is also possible here. Then understanding the direction and velocity and path of groundwater flow in the formation. So this is possible by tracer test. We didn't see much about the tracer test, but there are tools available to understand the tracer test. So here, whatever we had seen, we can understand little bit about the groundwater pressure from the fluid conductivity and temperature. Fluid conductivity and temperature log will help us, and also borehole camera can give us some idea about the velocity and path of groundwater flow. And in pollution reduction, we had seen an example of oil petrol bunk leakage from Canada. We had a look into a case study carried out around a petrol station. So such a understanding of movement of contaminants, movement of waste can be estimated from most of the logging methods, especially resistivity log, fluid conductivity very clearly helps us to identify contamination. I told you how saline water impact and fresh water mixing can be differentiated from fluid conductivity log, temperature log, and also radioactive logs, right? Some waste disposal, especially in oil contamination. We had seen how different radioactive logging methods were used to understand possible directions of migration of oil contamination, right? Source and movement of water in a well. So this is possible by injectivity profile. That means before and after injection. Also deploying flow meter, tracer logging during pumping, and what we had seen is the temperature log as well as conductivity log help us to know about the movement of water through the borehole. And all the physical and chemical characteristics of the fluid in the water can be understood from fluid conductivity and temperature logging, right? And neutron logging, we didn't see about neutron chloride, but neutron logging also help us to identify zones which has got higher amount of water. Obviously, resistivity log. We had seen how resistivity log helps to discriminate the contaminated zone from the less contaminated zone. We have seen wherever we have fresh groundwater, resistivity which we are measuring, electrical resistivity will be comparatively higher than the zones which has got saline water. Saline water, electrical resistivity will be very, very less. So we are able to distinguish zones which are having fresh groundwater from the zone that has got saline groundwater, and determining the construction of existing wells. How how the construction has been done, whether it has been done properly, where is the location of well screen, whether the well screen is properly functioning, can be understood from borehole camera method. We have seen borehole camera method, also by caliper logging method, then gamma logging method can also be used, right? Then cementing, whether the borehole has been cemented properly, can be also estimated by caliper log, right? And also by gamma logging. Whether the casing is corroded, this is very easy by camera, borehole television or borehole camera logging. Right? Borehole camera logging can be helpful to understand to see the actual physical condition of the casing pipe. Also the well screens can be clearly identified. Whether there is any leakage from the casings, right? We wanted to tap groundwater only from this zone, but from here there can be some contaminated water leaking into this. This can be identified sometimes by fluid conductivity, right? Fluid conductivity log or temperature logging, also with the help of tracer and flow meter, which we have not seen that, right? So out of the methods which we have seen, we can make use of fluid conductivity and temperature log to identify whether there is any change in the temperature in this zone or conductivity of the fluid in this zone due to leakage from the surroundings. So these are all there. On the left hand side, what questions we want or what information we want. On the right hand side, we have seen what will be the appropriate logging method, right? Come to conclude, the major advantages of logging method is it gives lot of information, especially information on the stratigraphy, that means the location of different formation and their boundaries. Hydrogeological information help us to also understand about the contamination of water, and we are able to understand the subsurface conditions, right? What is the condition of the formation below the surface? It can help us also to understand the process of groundwater remediation. In environmental parlance, the groundwater here would have been contaminated. This is the contaminated groundwater zone, and we are deploying some tool, some method to remediate the contaminated groundwater. Right? That means we have commenced a work to clean up the groundwater, contaminated groundwater. That means remediation is the process by which we try to bring back the conditions of the groundwater to the condition that was existing before the introduction of contaminants as far as possible, right? So when you are deploying such a tool, right, for example, we may be oxidizing, we may be adding some bioremediators into the system, or simply we may be pumping in air. Even aeration helps in cleaning, right? And as we continue this process, we can have a designated borehole. Over there, we can repeat the logging at different times, T0 or before commencement of remediation, then after 1 month, at or 2 months, 5 months, 6 months, we can repeat our measurement to see how our groundwater remediation project is working. These are all some of the advantages of different methods we have seen. Already I touched upon some of the limitations. One major limitation is very expensive. And geophysical logging is not possible in all the boreholes. Some methods are possible only in uncased wells. In cased wells, only radioactive logging methods are possible. NMR is possible only in PVC cased or uncased borehole. So that means different logging tools have to be deployed depending upon the condition of the boreholes, right? So they require some specific borehole conditions. The advantages, limitation and requirements of each borehole logging method must be considered while planning a investigation, right? Obviously, assistance of a geophysicist or a geologist may be required while carrying out the measurement in the field. And always the results have to be presented in a nice form. Usually, we had already seen the results are presented in the form of depth versus the signal, right? Depending upon the method, right? As we had seen previously, all the results are plotted on the same scale, kept one after another to come out with a meaningful interpretation. Obviously, the precise location, latitude and longitude, as well as the date of measurement of logging need to be kept in mind. As we had seen in the example of oil contamination, we would have carried out logging at the same site at different location. Inter comparison can be also made, so and they can be presented nicely in our report. Also, the location map showing the steady area location as well as the locations of the various wells wherein we carried out the logging need to be also presented along with the report, right? And these are all the different limitations of the method we had seen. So to conclude, we had a look into all these logging methods, right? Resistivity logging, cell potential logging. We had a look into induction, electromagnetic induction logging, right? Deep induction, medium induction, short induction logging. Then we had a look into the electromagnetic method. Then, so to conclude, these are all the different logging methods which we have seen. First, we started logging by looking into cell potential log, resistivity log. Under resistivity log, we had seen different methods of logging, right? Under resistivity, we had seen in fact 4 methods, right? Like such as normal log, lateral log, then guard log, micro resistivity logging. Then we had seen induction logging. These 3 are radioactive logging methods, natural gamma, which is a passive method. Gamma gamma and neutron neutron are active methods. Right? Then we had seen sonic log, temperature log, fluid conductivity log. Then we had also seen nuclear magnetic resonance logging, caliper log, and lastly we had seen borehole camera. So these are all the different logging tools which we have seen. Under this, I am sure you would have had an understanding of the possible applications of different logging tools depending upon the question which you may come across in your career or in your area of research. You will be able to choose appropriate logging tools to answer the questions which you have. But always remember, we have to answer the question with 2 or 3 tools to answer the question confidently. Thank you very much.